Hello, I'm your host Shlok Jain and welcome to the GeekyAnts talk show where we, a bunch of friends, gather together and discuss on certain topics, right? So in this week episode, we'll be talking about microservice architecture, and to discuss that topic, I'm joined here by my friends Shivam and Vasuki. Welcome guys, welcome to the show. Awesome. So before we jump into what microservice architecture is, let us talk how we came to microservice architecture, right? So the standard way initially before microservice architecture was something called as a monolith architecture. Right. So what happens in monolith architecture is the entire code is stored in a single unit, right? And it's mostly a monorepo as well, a single repository. So what happens is suppose let us consider an e-commerce application. In the e-commerce application, we'll be having the product catalog, the users, the auth service, right? Multiple services. All of this will be in a single unit, a single repo. So the issues that a monolith architecture initially faced was that if there are multiple teams working on individual components, right, they had to have a lot of coordination in between, because whose feature is going to go first, who's working on what, right? Also, it was like a single tech stack. Everyone has to follow a single tech stack, right? They couldn't change the tech stack of a particular component dramatically, right? Also, if suppose I am working on a particular payment feature of an application, and if that has to be deployed, the entire application had to be deployed. Right. So these were the few issues that we were facing in what you call in monolith architecture. Also, suppose if there's a holiday and a sale or as such, and a particular service has to be scaled to a large extent, right? So the entire application had to be scaled in this scenario. So that also led to huge infrastructure costs. To overcome all of these things, right? So we realized monolith had a lot of downsides. So hence we came to microservice. And in this week episode, we'll be jumping a bit more into deep as to what microservices is. So all right. So welcome guys. So Shivam, would you like to take up what microservice architecture is?
Yes. So let's start with a basic layman's term, what microservice. The name itself suggests micro and service. So we have small services which is responsible for each functionalities. So microservices is generally an organizational approach in which for the software development, in which we'll divide our software into small components, and each component is responsible for its own feature, so that it can be deployed very easily. And suppose I have a particular app or software, I have certain features in it. I will divide each feature into small component. And the best part is all the component will have its own code base. Okay. So it's very easy to maintain all the small feature, and combined together will come a microservice architecture.
Okay.
So that's a basic definition of microservice.
Yes. Yeah. So basically what is happening is we are taking as we mentioned, the individual services like the payment gateway or product catalog, all these things, and we're splitting it off from the monorepo and creating separate repositories for all and maintaining them as individual services. And all of them come and work together, and that's the microservice architecture.
Yeah.
Awesome. Cool. So, what are the advantages of microservice architecture? Why are we talking about this today?
Yes. So, what the first advantage I will like to put, it's very easy to deploy. So, we have multiple services aligned, and each services is working with its own feature. So, it's very easy to deploy a particular service, and it's not required like everyone should work on a particular service. Exactly. And we don't have a coding restriction, like each service should have in the same language or in a same structure. We can follow multiple languages, multiple structure, everything, and that can be combined together to make a single application. And second thing, it's highly maintainable. So maintaining a microservice architecture is very easy. We can easily maintain a microservice architecture. And the testing part is also easy. We have a particular service to test. Each service its own point. Suppose a payment gateway we have. Its only work is to have the payment options. Okay. We have a user authentication feature as a microservice. The main feature is like, it will access, so it has to authenticate a particular user. So that's the main feature. The next part I will tell, it's very organized architecture. If you will have the clear architecture where how everything is deployed, it's very easy to maintain. So that's, I think, some of the advantages.
That makes sense. So, okay. So as you mentioned, we can deploy it very easily because only if one part we're working on it, we can test that easily and it can be deployed. Also, it requires a small team, right? We can use the man force much more effectively, right? The coordination is like improved because, there no need to be intercoordination between different teams working on different services. Also, it's not tech specific as you mentioned because we can have different tech stacks as well. Also, it is loosely coupled. Basically, it's not tightly coupled. So if you want to deploy deploy it, we can deploy it
yes.
individually.
Yeah.
Also, it is maintainable.
Yes.
Cool. Awesome. Okay. So, I'm sure pretty sure there are some key differences, right? Some core differences apart from obviously the disadvantages and advantages. What are the key differences between microservice and monolith architecture? Vasuki, would you like to take that up?
Yeah. So basically, in a monolith, right? You take any e-commerce website. Take your example itself. In an e-commerce website, if we design it in a monolith, right? So your pricing details, your product catalog, your SKU management, anything and everything is in one single data source, right? So you have one DB and you have one service, and everything is managed through that, right? So the main difference comes up over here in microservice architecture, right? So the main defining point of a microservice is each and every microservice has its own data source.
Okay.
Right? That means it has its own database. So now let's say I have a SKU management engine, right, which also has a pricing information, right?
Okay.
So anything that I need to change to the price, right? Say, let's say we have a taxation engine, right? So we as of now we have 18% GST. But tomorrow, let's say it becomes 15% or it becomes 28%, anything of such sort, you just go ahead and change it in one single point, right? And it is, as he said, it is deployable on a singular basis, right? It's a very isolated environment, right? So changes to the data structure in the pricing engine is not affecting any
other part.
Right? So in a monolith, you touch the pricing engine, you don't know what else will be.
Exactly. Yeah.
Right? You need a complete rebuild. You need a complete sanity check end to end that is happening in the monolith. But that's not the case over here. Right? You just need to make sure that integration holds up. Your abstraction holds up. Right? So let's say you are sending a price in decimal value up to 3 digits. That's an example, right? And a lot of services are consuming based on that. The only thing that you need to make sure is you're sending that value in the exact same format, right? So that your abstraction doesn't break and everything else is good. You don't need to go ahead and do a sanity check anywhere.
Exactly.
Right? So that is one of the main key
differences between monolith and
microservice.
Okay, but why would I want to choose microservice architecture? That's my thing. So why would I think so it's business case, use case specific, right? Or if you don't have a large application which doesn't have necessary for multiple subdivisions of services, like, if it can be maintained in a monorepo, so that would be a good choice to not go for microservice architecture. But apart from that, are there any reasons as to why I should choose microservice over monolith?
Yeah, so major part is scalability, right?
Okay,
Component level scalability.
Okay.
Right? So let's say currently the Big Billion Day sale happened, right?
Yeah.
The iPhones came into a pretty incredible price range, right? Now, the thing is, you don't need to scale up anything and everything, right?
Yeah.
You just need to make sure that the SKU management of mobiles department needs to scale up, because that is where all these offers were happening, and only those things need to scale up, right?
Yeah.
So in a monolith, if you want to do that, you would have to scale up
the entire project. Yeah. Also, it costs.
Flipkart needs to scale up.
Exactly.
It is very cost inefficient.
Yeah.
Right? Because
infrastructure cost increases dramatically because unwanted things will also be scaled. Exactly.
Yes. Yeah. Right. In component level scaling, you're just scaling up one single component, which is lightweight.
Yeah.
And it is again, it is always fronted by a load balancer and everything. Your load is distributed. Right, so your each and every component is running at its own load.
Exactly.
Right. So that is one of the main reasons why you would want to use a microservice. And also, as I said before, data abstraction. You change in one single point, and you know for a fact that nothing else is breaking.
Yeah.
And also, it is easy to maintain a particular code. Right, maintaining a pricing engine became a lot more simpler by isolating it. Right.
Shivam, I think so. You also,
yes.
Yeah. Thank you for that insight, Vasuki.
Yeah.
Shivam, I think so. You also wanted to add as to why to use microservice architecture, right?
Yes.
There was a point you were discussing earlier. Would you like to add something to that?
Yes. So, using a microservice architecture, that totally depends upon your use case. Like, what's the use case you have? What's the actual requirement you have? So, the requirement analysis is the most important part to choose which architecture to use. Either go for a monolith architecture, microservice, or something else.
Okay.
That totally depends on your use cases. Suppose I have a very simple application in which I have only, suppose a user will log in, a user will send a text. Normal, simple application. So why to use a microservice? Why to make the application complicated? And another thing is microservice architecture is very good. On the other hand, it should be architectured in a very beautifully mannered. If it is not architectured well, so it will be very difficult for everyone. So it won't be that much sufficient. So if we have the requirement, we have multiple services, then it's very good to use microservice. Otherwise, monolith is a good solution yet.
Okay. Vasuki, you were telling me about the abstraction part, right? So that got me thinking. So in microservice architecture, we can have different services having the same database and different services having different databases, right? Like a database specific to a particular service. But that need not be the case, because I have seen many implementations where it's not 100% correct, but there are instances where a single database is used across multiple services. So would you like to tell me as to how to go about shared databases and different databases? Or Vasuki, would you like to take that up?
Yes. So
in microservice.
Yes. So generally, if we are converting our monolith application to a microservice application, generally what we'll do, we'll keep the database common and we'll separate out the functionalities. So that also depends on your use cases. So suppose we can separate out the whole database only, and we can use that particular database as a different service that will provide you the database access only. So that can also be done. Some of the organization are doing that also, but it's recommended to use a shared database because each service is responsible for its own database, and that will be very easy to maintain. So suppose a user authentication, so that can be only accessing the user information, and if some other service wants that information, that can be easily shared with like well-defined APIs. We have APIs to communicate between the services. So I think the shared database is still a better solution to go for a microservice architecture. I think Vasuki, you want to add up any point?
Yeah, so basically, as per the definition convention goes, right, it has to be one-to-one, right? Each microservice has its own data source, right? But as you said, while migrating from a monolith to a microservice, you already have a huge production database. There's a lot of data that is already being structured into a database, right? Now you can't go ahead and nuke the DB into multiple pieces, right? That will be an operations disaster to get everything sorted, right? So what we usually do is we either share the DB with multiple services for the time being, or what we do is we use some tools like Hasura, right? We deploy it onto the DB. So now what this does is, see, Hasura is a microservice, right? It is a simple microservice, one-to-one mapping, right? Now it is abstracting the whole database, and it is giving us some set of GraphQL APIs through which we can communicate into DB, right? So now what we can do is we have a huge DB. It's already populated, done everything. You deploy Hasura over that, and then use that Hasura APIs to connect all your microservices, right? So your data sync is one singular point. One singular API, single microservice. You can call it as a data source API. All your services talk to your data source API and get the job done. So the read write onto the DB is only handled by Hasura. Right. So in that case, you're again abstracting it.
So I think so. People need context about what Hasura is. We just jumped into Hasura because we discussed all that earlier. But I think so. Viewers might not be able to get to know what Hasura is. So let's not jump into that as of now. So speaking of, I think so. Shivam brought a good point. He told that suppose if we are keeping one database for one service, right, and if another service needs to access data of the other service's database, it can do it by well-defined APIs, right? So that got me thinking. Anyways, we've learned what microservices, and we've understood that so microservice basically multiple services, splitting it into multiple services, so different repository or single repo as per your requirement. We'll come to that later. So how do these services communicate, right? So communication of microservices, that is something we need to talk about. So that it predominantly happens by three ways. First one is by normal HTTP requests. We can have HTTP requests between each single services, right? So if one service wants to call a service, it can make like a context call, right, or a HTTP request. The other way is using message brokers, right? So what message broker generally does is it passes it to a queue, right? And that queue then forwards it to the next service, and then it internally communicates. The entire context is passed to the queue, right? That is how we can access. The third way is something called as a service mesh that is started. So service mesh is basically an entire fabric in which all the different services run, and within this fabric they can communicate easily, right? So these are three methods that inter-service communication can happen in microservice architecture, right? Cool. So I think we have learned what microservice basically is, right? What Monolith was, why from Monolith we came to microservices, right? And implementation of microservice, we'll come to that later. So let's talk about some more advantages and disadvantages of microservices, right? Because let's take it as a full picture as to what are the pros and what are the cons, and how we should consider and not consider, what loopholes are there. So let's deep dive into it. So advantages of monolith architecture. Would someone like to take that up? Vasuki, would like to take that up? Benefits of microservice architecture.
Microservice architecture, right? So the major key benefit is maintainability. That is the core principle of microservices. So you can maintain your business in a much more simpler way when it is architected properly, right? So, and also in terms of achieving business goals, right, building a new feature or anything, it is much more faster because we can have multiple teams working on it asynchronously. They don't need to wait to any other team to have it done or anything. You get a feature. If it's an independent feature, you go ahead and you finish it, done, right? Also, even if it is an integration feature, right? Let's say it is being talking to multiple services, right? Even then, your feature development will happen in parallel. The only point of synchronization that you would need is while integration, making sure all the services are working fine. It's mostly making this context calls using a message broker or HTTP API and making sure everything is working fine. All the server features are working fine. That's a major benefit of it. Right? So this enables the business to fail fast, right? So you can try out anything. If it doesn't work, okay, chuck it, remove the module outside, bring something that works, right? So it basically gives a lot of flexibility to the business to experiment and make sure they get the things right. At the end of the day, whatever services you build, use a monolith or a microservice. At the end of the day, if the business is not making money, everything is
it makes sense. Right. It's good. So Shivam, what are the downsides of microservice architecture?
So though it's a very good architecture, it's well organized, well managed, but it has its own disadvantages. So coming to the disadvantages part, so since it's a distributed system, so if we have multiple services, like the number of services we are increasing, it's very difficult to maintain also. Like we need to maintain each and every repo for its own service. And testing, like finding the bugs. If it is not organized properly, the architecture is not proper, then it's very difficult for a developer to find where the bug is actually happening. Though it gives a very good feature of deploying individually, but individual deployment will also can be it won't be good for some reason. Like suppose if you are working on a particular feature and that feature is dependent on some other feature, so if we will think in that way, it will affect that feature. That is a natural way.
So basically, if one service is down, it will hamper
it will hamper the other service as well. If all the dependent service,
inter-service dependency.
Yes. So the inter-service dependency is very, and the main reason is like you have small teams working on the different architecture generally in the microservice. Suppose one team is working on another service, another team is working on another service. There can be a communication gap, which is generally seen in the production environment. There is a communication gap between one service to another service. So it's very difficult to rectify those things if there is a communication gap. I think Vasuki, you ought to add anything.
I think so. With respect to some of please continue.
As you said, the major communication gap. He told a part of the technical thing. that is also true at the human side, the developer side, right? There are multiple teams developing. That is also one of the major advantages where we can have development in parallel, right? At the same time, if there is a communication gap between these teams, and when it comes to integration, everything just fails.
Yes.
Right? Because there is a gap. We haven't thought of some use cases that they have thought of.
That happens. Yeah.
And they're like, you have to pass this one particular field. We know that we need to get that one particular field.
Yes.
That needs to be
something.
I will tell you one interesting story before that. Coming to this point, we had one issue recently. So we both are working on a same project, and he is working on one service. I was working on one service. I made my service. I made like all the API calls. What will be the API calls? And somehow that API is not working because it's dependent on his service. So there is a particular field which he added on his service, and I didn't take a pull of that particular service. So because of that little communication gap, I had to debug the whole code, like what is wrong with my code, till it was not working now. So that is the major disadvantage.
It causes at times brain freeze.
Yes.
Right?
Yes.
This is a common issue between Monolith and MicroServices. In MicroService, the thing magnifies because, let's say, for a thing to get done, right? Let's say, for a thing to get done, let's say we have a chat application, right? You are sending a message to one of your recipients. Let's say there are around 10 services involved in this pipeline, right? Now, while giving KT to any other person end-to-end flow, right? You need to give saying that this is service A, this call service B, this does something and call service C for something else.
So where is it breaking? That's where the issue is.
Debugging becomes a huge issue if we haven't architected things properly, right? Log aggregation.
I kind of find that funny because in the advantages we kind of mentioned, that it is a single code base, easy to maintain, easy to test. So I think we had to add a caveat that it is easy to test this particular service.
Yes.
So if I'm working on payments, I'm sure that the payments will not fail because I have tested this end to end
with my conditions.
With my conditions. Now, will it communicate with other service? I have to make sure the endpoints are well defined, the abstraction is properly maintained. So that is it. So the issue arises now in testing. We ensure that our service is tested properly. The thing is, where it is breaking in respect to other service, that is a bit difficult to track, right? And if other service is down, that is one issue arises, right?
Yes.
Also, another thing I want to touch, since Shivam mentioned a downside of code maintainability, right?
Yes.
With respect to multiple repositories, I think so. There are two different ways how it is maintained. Like a microservice can also have a monorepo, where in a monorepo we are subdividing it by terms of folders, right? Where a single repository has it's called as a group. I think so. It's called we group the entire project, right? In that we have separate, like we can have different services. Also, the contrast to it is the polyrepo or multi. Polyrepo is multi-repo, where single repository for different things. That is where you face the issue.
Exactly.
All right, cool. So we've covered that. Now let's jump to architecture a bit more, right? So a thing that I find fascinating is, in terms of, we say that it is easy to deploy in microservice architecture, it is easy to scale in microservice architecture. But one thing that we kind of miss out is that you need to have a very good CI/CD pipeline setup for deployment. Because let us consider, suppose say Amazon, any of the top companies, right, like an Amazon, Flipkart, or any huge corporation, they have so many microservices. Like you can just, let's take Swiggy for example. I think so Shivam came up with a very good example of Swiggy, how they've just purchase another company, and it is very easy.
Dino. So we can see the recent Swiggy. We can take the use case of Swiggy. So it has the food delivery, the Instamart. Now they purchase the Dino. So they included. So the including part is very easy for them.
Exactly.
So they're just, it's a microservice. They will come and they will integrate in the same app platform, and that will work for them.
Exactly. Yeah. So coming back to the deployment aspect of it, a very, very well-defined CI/CD pipeline is required because these big companies have like thousands of deployments, like hundreds of deployments daily, right? So that is, so you need to have a very good DevOps team in general. Also, I think so you would like to take up a bit on architecture of microservices, right? I think so there was something with Kubernetes you wanted to add.
Yeah. So basically, in my microservice, right, a microservice can be deployed into a bare metal machine, or it can be used containers, right?
Containers.
I mean, this is something This is something that is true for both Monolith and microservice. This is not something that is very specific to microservice, right? The specificity comes into play when we bring in Kubernetes.
Okay.
Right. So Kubernetes is a tool which is used to orchestrate all the containers, right? So let's say we have multiple containers running, multiple components. If we talk in microservice terms, a lot of components running as containers, and you want to orchestrate it, right? You want to have the logs in one single place. You would want to monitor all your services in one single place, and you should be able to scale up each and every component vertically and horizontally, right?
Yeah.
Individually, independently, and also preferably automatically, right? Also, you should also make sure that the service doesn't go down. If it doesn't go down, what is the policy of bringing it back up? Right? So this is where Kubernetes comes into its own, right? It is orchestrating everything into one subnet. Exactly. And
that takes care of everything. So if something goes down, Kubernetes will take care of
it has its self-heal thing. We have horizontal pod scalers which will give you auto scaling. It pretty much does every single thing for you, right? In terms of operation stuff. But again, that's a very simple way of telling it. There are a lot of complexities involved inside Kubernetes. That is something that we won't be going deep dive into today. But yeah, that is also a way of managing microservices, right? In the deployment environment. Kubernetes helps you to basically make sure that your service is up and running 24/7. And also there is no downtime. So because once you bring up a new version of the container, until and unless Kubernetes is sure that it is ready and live, it doesn't bring down the old container, right? So it reroutes the traffic to the new container and it gracefully shuts down the old container. So there is no downtime over here, right? So in a monolithic architecture, even though you containerize it, right, you have to bring down the container, you have to bring it back up. It's a whole lot of processing.
Good. So I think this use case which Shivam brought was quite insightful. Would you like to add something more? So the Swiggy's use case was very insightful.
Yeah. So just take an example of any use case, like when we develop a microservice architecture. Let's take example of a shopping application. So we have multiple services which we can separate out, and each services can do its own work. Suppose we are making a shopping application. So the first service which we need is the user authentication service, which will helps the user to log into the service. The second service can be to fetch the list of the available items I have. That service is only responsible to get the items. Third service, I will take fourth service for example. Third service can be the cart, and fourth service which will be the payment option. Suppose the benefit of the whole architecture is like, suppose I have my payment services down for a particular time, for some time, or it's getting developed, or it's getting updated, for any reason. All the three remaining service, that is the user authentication, the second the cart service, and to fetch all the list of items, that service can go up parallelly. That won't affect in a microservice architecture. But if we'll build the same application using a monolith architecture, that will be a very difficult for us, because for updating the payment condition, we have to update the whole application, and for the particular time, all the other services won't work. So that's the use case. Generally will divide. Exactly. So the first thing I will say is the requirement analysis. Like, what's the requirement you have? Write down the requirement, make the proper flow charts, separate out the services, give time to making your services, because if your services are not well organized, it's very difficult to maintain a microservice architecture.
Exactly.
So, and if the other way around also. So if your services are well organized, it's very easy to maintain, upscale and downscale, because upscaling and downscaling are two different concepts. I think Vasuki
coming to that. I think coming to that. So as I told, it is very difficult. So and to enable it, we, as Vasuki mentioned, we have technologies like containerizing it, dockerizing it, and Kubernetes, right, to enable microservice. As coming to scaling aspect of it, how do microservices scale? Vasuki, would you like to jump into that?
So microservices, basically we have two scalable points. Right? Either it can scale it horizontally or we can scale it vertically.
Hmm.
Right? So let's say we want multiple components running, so multiple instances of a particular microservice is running, right? So in Kubernetes, let's say Kubernetes itself has the base platform tool, right? So it becomes a lot simpler to understand how it scales. Right? So let's say in Kubernetes, you go ahead and say that at any given point of time, I need 3 instances of this service running. Right? So let's say product catalog. Out of everything in an e-commerce website, product catalog is the one service which has to be highly available, because anything and everything in the product page, product details page, or the landing page, listing page, anything and everything is hitting the product catalog itself, right? So product catalog has to be highly available. Right? So let's say you say I want at any given point of time 3 instances of this running, and based on load, based on network load or based on system load, you set up some scalable pointers, right? Let's say after 50% of its usage, bring up another node. Right? Then 50% of the collective usage, bring up another node. So you will set a maximum node set, right? You need a minimum of 3 and you need a maximum of 6. Right? So based on the delimiters that you've given, it scales up. Right? But while scaling down, it is not that straightforward. You hit a particular point, it scales up, right? But while scaling down, that's not the point. Right? So it has to gracefully shift the load. Right? So let's say you have 8 instances of the server running. At the end of the day, it has to come back to 3 because you said that minimum I need is 3. So let's say the load has come down, only 3 servers can handle it. Now it has to come down. So now what it does is a lot of servers are serving this data, right? So what we actually do is a graceful downscale, right? So we make sure that server is not serving any more requests. We shift the current services into the existing servers, and we shut down
the first one.
We shut down the first one, then we shut down the next one. So downscaling is a much more slower process. Right? Because that affects a lot of other things going
being served.
So at the end of the day, we come back to the initial starting point, initial state, which is the 3 services. Right? So this is in terms of Kubernetes. It also holds good for anything and everything else. Right? Inside the pod as well, when you're doing vertical scaling in terms of multi-threading and all, inside also it is using the same concept, right? Until unless every thread has done its execution, it doesn't roll back to its initial state. At initial state where it is using 2 or 3 threads to maintain everything, it won't roll back to the initial state until unless the load is properly distributed and cut down to its minimum point, so where it can delete anything and everything. Right?
Awesome. So that has been really insightful. I think so. We have a very good understanding of what microservices. And now let's jump to this new section of our show, which we call as the 120-second rundown, the summary section. All right. So before we jump into microservice architecture, why we decided to choose microservice architecture was because the standard architecture before microservices was the monolith architecture, where it was a single repository, a single code base, where a single code base had multiple services, and they had issues. The issues being that there was a lot of issues with communication and coordination between teams, and it was tech stack specific because they cannot change tech stack at a particular component because the entire project would be affected. Also with that deployment, because also if only one thing has to be changed, the entire project had to be built. Also if it has to be scaled, if only a certain aspect has to be scaled due to a particular business requirement, the entire project had to be scaled. So it was very infrastructure effective, like infrastructure cost would be very high. So to overcome all of this, we came up with we have come across a new architecture called as a microservice architecture, where everything is split into separate services, right? And these services are responsible. Usually they have their own database, so one database for one service, and they can communicate with each other. So how these services usually communicate is there's predominantly three ways. The first one is using well-defined HTTP APIs, right? HTTP calls using well-defined APIs. The second way is using message broker, right? So a message broker is basically you pass the entire context and the request inside a queue, and that queue will redirect the request to the next service, and that service can access the database and so on, and then they can communicate, right? And also the third one is the mesh, service mesh. So service mesh is the entire framework in which all the services are individually deployed and they can communicate within that mesh, right? So that's how microservice communicates. So advantage of microservices, it is highly deployable, right? It is easily testable because one part of code can be tested and deployed easily. We can change tech stack at one particular service and other services would not be hampered. Also, it is loosely coupled, easily deployable, and it is based on the business, right? Based on the business requirement, we can have it. So if it is highly scalable in future, if there's a new business requirement, we can just add another service and make it communicate, right?
Yes.
That will be a cool thing. And difference between Monolith and Microsoft Architecture, I think so advantages and disadvantages kind of splits that out. Yeah, but then also this has a disadvantage because the advantage also have a flip side based on the use cases. If there's it does improve coordination of teams, but then if one particular service has a drastic change and other person is not, we need to have well-defined endpoints and we need to have a decent process of it. Also, it requires a lot of CI/CD pipelines to be installed in a smooth fashion for the deployment to take place very easily, right? The issue is the advantage is that it is easily testable. Each service is easily testable, but when it is deployed, we might encounter an error, a test issue when it goes to other services, right? And then when the issue is through other service, because there's a flow of the code, and if then it fails, it will be quite difficult to pinpoint as to which service the code is being the error is being generated from. We have multiple components, right? It is built for a particular business. It is easily deployable. It is failure resistant, right? And also it is evolutionary. And we've come across some cool use cases as to how microservices is being used in real life. And that's about it. So I think so. I hope you guys had a very insightful show and you guys got to learn a bit about MicroServices Architecture. Thank you guys. Thank you, Shivam. And thank you, Vasuki. All right. So I'm your host, Shlok Jain. Thank you for tuning in to the GeekyAnts Talk Show. We'll come again next week with another cool topic. So till then, it's me signing off. See ya. Bye-bye.